Picture the final hour of the universe. Not a slow fade into darkness, but the opposite. Every star in the sky rushing closer, brighter, hotter, the entire cosmos closing in like a fist. If new dark energy data holds up, this is not science fiction. This is one of the leading models physicists now take seriously for how everything could actually end. For 20 years, the accepted ending was the Big Freeze, a universe expanding forever into cold, dark emptiness. But calculations published by a Cornell physicist in 2025 suggest a different and far more dramatic ending, one where the universe reaches its largest size in about 11 billion years, then reverses and collapses back down to a single point roughly 20 billion years after that. Physicists call it the Big Crunch. And the final moments, if it happens, would be unlike anything that has ever occurred in the history of the cosmos. The process begins slowly, almost unnoticeably. Billions of years before the end, the expansion that has been carrying galaxies apart since the Big Bang simply stops. Space stands still for a moment on a cosmic scale, then starts moving the other way. Galaxies that have spent billions of years drifting apart begin drifting back together. Gently at first, then faster and faster still. Gravity finally winning the tug of war. It has been losing since the beginning. As the contraction accelerates, the cosmic microwave background, the faint afterglow of the Big Bang that currently sits just a few degrees above absolute zero, starts to heat up. Compressed into a smaller and smaller volume, that ancient light grows brighter and hotter with every passing million years, until it becomes hot enough to cook stars from the outside in. Astronomers who have modeled this scenario describe it happening star type by star type. The coolest stars go first, unable to release their own heat fast enough into a universe that is heating up around them. Then hotter stars follow, one class after another, boiling away in sequence as the background temperature keeps climbing. In the final minutes, everything that once felt permanent comes apart. The temperature becomes so extreme that atoms themselves start to break down, electrons stripped from nuclei stripped down further still. Structures that took billions of years to build, stars, planets, the atoms in every living thing all get erased in a fraction of a second. Every black hole in the universe, once isolated by unimaginable distances, finds itself surrounded by the same collapsing storm of matter and radiation, swallowing everything nearby, and as the black holes themselves are pulled together into an ever denser, ever hotter final mass. Here is where the physics we currently understand runs out. As density and temperature climb toward truly infinite values, the two great frameworks of modern physics, general relativity and quantum mechanics, stop giving consistent answers. Scientists studying this scenario are honest about it. Their own models cannot predict what happens after the collapse itself, because at that point the mathematics breaks down entirely, the same way it does at the center of a black hole. Some physicists have speculated the crunch could somehow trigger a new expansion, a bounce into another cycle. Others believe it may simply be the point where any physical description reaches its absolute limit. The scientists behind this calculation are careful to stress that none of this is settled. Their model relies on a specific reading of recent dark energy data, one that other researchers have already challenged with different analyses. The timeline, 11 billion years to peak size, another 9 billion to collapse, rests on measurements that will be tested and refined for years by upcoming telescopes built specifically to settle this question. What is worth sitting with is not the certainty of any particular ending, but how much this reveals about the limits of what physics can currently describe. We can trace the story of the universe back to its earliest fractions of a second, and we can build careful mathematical models of how it might end. Yet the true final moment, what actually happens at that point of ultimate density, remains completely outside what any equation we possess can capture. Some questions about beginnings and endings may simply belong to a kind of knowledge our instruments were never built to reach. What do you think? Is the universe more likely to freeze into silence or collapse back into fire? Let me know in the comments. Subscribe, because next time we are covering something Webb found that connects directly to this story. A black hole that appears to have formed before its own galaxy, and why that sequence should not be physically possible.